Okay, everyone. So this is section 3.5. We're going to talk about rational functions and their graphs. Um, so, so a rational function is defined to be basically you have a numerator and a denominator, right? So a rational function is a fraction in which the numerator and the denominator are both polynomials, right? So these are polynomials written in their standard form. Notice they don't have to have the same degree. The degree of the numerator is n, and the degree of the denominator is m. So n could equal m, but not necessarily. So that will come up later. And right before we start talking about their graphs, let's review what we mean by the domain of a function. In particular, for a rational function, it's just the set of all values of x, the set of all x, such that the denominator does not equal 0, right? So in our first example, I guess I'll call this example 1, right? We have the function y, or f of x, equals 1 over x minus 2. So example 1. I'll call it f of x, but it's the same as y. 1 over x minus 2. So how do we find the domain? Well, you take the denominator. In this case, d is just x minus 2. And you do what you're not supposed to do, right? You set it equal to 0. And when you solve for x, you just add 2 to both sides. You get x equals 2. Okay, so that's not the domain. In fact, the domain is everything else. Everywhere x does not equal to 2, right? So that's for the domain. And just to review interval notation, you're going from negative infinity to 2, union 2 to infinity. Okay? Okay, so that's to find the domain. Now, one feature of these graphs, of the graphs of rational functions, is that they typically have what are called asymptotes. So what is an asymptote, right? Well, they come in two varieties here. Actually, there are asymptotes that are neither vertical or horizontal, but in this course we're focusing mostly on vertical and horizontal asymptotes. All right, so what is an asymptote? Well, it's a line, right? It's a line. So a vertical asymptote is just a vertical line, right? And a vertical line has an equation, for example, x equals a. So that will be a vertical asymptote for the graph of a function, f of x, right? When, as x gets close to a, right, either from the right or left, that's the plus or minus, the function, the y values get bigger and bigger or smaller and smaller, right? So they either go, right, the y values go straight up, right, or straight down. Well, not exactly straight, but close, right? Pretty close to straight, right? So, right, so our first example, right, so I already graphed it over here on the right. This is the graph of, I can write it down again, 1 over x minus 2. So the blue is the blue, that's the blue graph here. That's the graph of the curve. And this red line here is the vertical asymptote, right? Because it is the, right? So this red line here is x equals 2, right? So this is a vertical asymptote. Right, so what makes it a vertical asymptote? Well, so just looking at the blue graph, that's the graph of this curve here, you can see that this curve gets closer and closer and closer to this line, right? You never get there, but you get very close to it. So essentially a vertical asymptote is a line that the graph, the curve, gets closer and closer and closer to that line. In this case, x equals 2. So that's what in this case, a vertical asymptote. Now, this graph also features a horizontal asymptote. It's a little harder to see here, but if you look at the x-axis, this is the x-axis here, in fact this is the line y equals 0, the blue graph also gets close to that line. Okay, so the line y equals 0 is actually a horizontal asymptote, and I'm going to run out of space, so let me abbreviate horizontal asymptote. Right? So we have one vertical asymptote, that's the red line, and then we have one horizontal asymptote, that's the x-axis, which I did not color in just because it's already the x-axis. So, right, so that's something that you're going to see when you see rational functions like 1 over x minus 2. Okay, all right, so if we're just given the equation, how do we find the asymptotes if we don't have the graph like we do in this case? We'll get to that in a little bit. So before we do that, I want to look at one more example, just looking at the graph first, and that's going to be, well, this one here. I guess I'll call this example 2. So y equals 2x over x plus 1. Okay, so I'm going to scroll down a little bit because I already have it graphed. It's way down here, right? So this is example 2, and I'll call it g of x, right? This is 2x over x plus 1. Okay, so so that's the blue graph again here. These blue curves, right, is the graph of this function. The red line here, again, is the vertical asymptote, right? And so the red line is x equals, so if this is 0 here, you're going 1 to the left, it looks like x equals negative 1, right? So that's our vertical asymptote. Okay. But you notice the horizontal line, this green line here, is also an asymptote, but it's a horizontal asymptote because the blue graph here also gets close to that green line, both on the left and on the right. And so that green line here, in this case is y equals, so let's see, if this is 0, it's bumped up 2 units, so y equals 2, and that's going to be our horizontal asymptote, right? So looking at the graph, and again, it might not be as clear if I didn't already highlight the red and green lines as being the asymptotes. But it's basically the line that the curve gets close to. Okay. So looking at the graph, it should be at least reasonably clear in most cases what the asymptotes are, right? And not all graphs have asymptotes, certainly not vertical asymptotes, and not all graphs have horizontal asymptotes. But when you see rational functions, that is fractions like this, you have a numerator and denominator, typically you are going to get asymptotes, although not necessarily. Okay, so I hope that helps at least explain what asymptotes are. Asymptotes are just lines, right? Because you can have a vertical line or you can have a horizontal line. And oops, sorry, I messed that up there. Yep, so y equals b, or in the first example, it's y equals 0 here is the horizontal asymptote. And in example 2, if I can scroll down again, example 2, it's the line y equals 2 is the horizontal asymptote. So yeah, looking at the graphs, it should be fairly routine to figure out what the asymptotes are. And, you know, again, it might not be clear in all cases, but if you just have to look far enough, either to the right or to the left or up and down to see what the curve is getting close to. Okay, so that should be graphs of rational functions and their vertical and horizontal asymptotes.